Hello, chemistry students. Today we're going to talk about how volume is related to the mole. So we've already talked about representative particles being equal to 1 mole, which is always the 6.02 times 10 to the 23rd. And we know that this can be atoms here. This can be molecules. And hopefully you're getting better at writing out your units as far as seeing if it's just calcium that it's an atom, or if it is an ionic compound that it is a formula unit, covalent bond, it's a molecule. And we know that that is equal to 1 mole. Okay, so last video we saw how we could go from this and we could then use our mass conversion, and where 1 mole is equal to either the molar mass of a compound, or we had that atomic mass for just an element that we could find on the periodic table. And this is extremely helpful for us in the lab, and kind of lets us communicate what's in a chemical reaction that we do on paper into an actual reaction that we're going to do in the lab. Okay, so we have one more conversion factor. This one you can't use the mole hole, so you kind of have to just memorize the volume. Volume is that 1 mole is always equal to 22.4 liters, and this is always of a gas. Okay, and what this is Avogadro, he proposed the idea or the theory that that no matter the size of the particle, whether it be a really big gas particle or if it was a really small gas particle, that there would be the same number of gas particles if it was at the same temperature and the same pressure. And he calculated that 1 mole would be equal to that 22.4 liters. And this is at STP, that means standard temperature and pressure, right? Temperature and pressure. There we go. Okay, so as long as it's at STP, we can calculate this mole for any given gas or volume. Okay, and the conversion factor that we're going to be using with this, that kind of goes along with the volume conversion for the mole, is density, which I've already introduced that to you. And density, remember, is the grams per liter. So it would make sense that we could use this mass conversion and this volume conversion together and be able to do some pretty interesting calculations, because if it's grams per liter, if we have grams per 1 mole from this mass conversion right here, and if we set that equal to, or do a conversion factor from, this would be our 1 mole per liter. And if you look here, this right here, the moles would cancel out, is grams per liter. And so density will have a unique role in this lecture that we're going to do today over volume. Okay, so let's go ahead and let's do a couple examples of our new volume conversion factor. Okay, so let's just start off with an easy example. The one here in your book on page 301 is the sulfur dioxide, which sulfur is sulfur dioxide. They're both from the P block, and so we know it's a covalent compound. So sulfur would be an S, dioxide would mean 2 oxygens. Okay, and it says it's the gas that's produced by burning coal, and it's an air pollutant. It's one of the causes for acid rain. So I think we used this example earlier when we were drawing structures, talking about acid rain. And it says determine the volume in liters of 0.6 moles of this sulfur dioxide gas at STP. So if it's at STP, we know right away that we're going to be using that 22.4 liters. So let's start out with our given number, which was 0.6 moles of SO2. Now, I know a lot of you really are not wanting to write these units out. Okay, I can't stress enough how important that is. Okay, then we draw an X and a line, and we put moles of SO2 on bottom. Okay, so when I'm coming around and looking at your work, this should be, if you are stuck, this should at least be the minimal amount of work that you have done, because without even reading the question, you can find your given number and cancel out your moles. Okay? Now the only thing that goes with moles is 1. Okay? And now it just depends on where we're going. If it asked for how many atoms of SO2, we'd put 6O2 up here. If it was asking for how many grams of SO2, we could put molar mass up here. But it is asking for how many liters. So we see this liter, and it's set at STP, and so we know that we're going to be putting 22.4 liters of SO2 up here. So now our moles of SO2 cancels out, and now we just have 0.6 times 22.4 because it is on top. Okay, and let me get to the calculator here. My children. Okay, 0.6 times 22.4 will give us 13.44 liters of SO2. Now, remember, most teachers will give you 1 point for setting up this problem correctly, using the correct conversion factor, canceling out your units, etc. 1 point for the correct answer, 1 point for the units being correct and canceled out, and then 1 point for correct scientific notation and significant figures. So in this case, we would need 2 significant figures, and so our answer would be 13 liters of SO2. Okay. All right, so let's go ahead and do another one. And let's use that idea of density so you can see an example of that. Okay, so it says the density of a gaseous compound containing carbon and oxygen can be found to be 1.964 grams per liter. And as soon as I see that grams per liter like this, I just change it into a conversion factor whenever you're doing dimensional analysis, because this right here is essentially the same exact thing, and it's more useful to us when we're doing dimensional analysis. Okay, so this is the density of something. And it says, what's the molar mass of the compound? Okay, so we can assume a couple things. We know that we can get to the mole by using our new conversion factor. 1 mole is equal to the 22.4. Now, I know it didn't say what is the moles, but it is asking us what the molar mass is, so it'd be 1 mole. We're going to have to use that mass equation. 1 mole is equal to the molar mass. And the only way that we can get from here to there is by adding in this guy right here, because we need this mole so we can get into this. Okay, so let's try setting this up. So our given number then is going to be, well, we're not really going to have a given number. We're kind of going to just start off with 2 conversion factors. So if we have this 1 liter, now we're just going to want to use this guy so that we can get molar mass. So the way to do that, if our molar mass is moles per mass, we would want to put moles on bottom here so that the liters will cancel out. Okay, So now if our liters cancel out, our units at the end are going to be grams per mole. Okay, so that's exactly what we want, because grams per mole is what your units are for molar mass. So earlier when we did that worksheet for molar mass, you would write the number and then you put it over 1 mole. So your answer was something grams over 1 mole, and that was because the conversion the number that you end up with, the units, are grams per mole. So let's go ahead and calculate this. That one's a little difficult to set up, but I wanted you to see how we can use that density to help in our favor to calculate many things. So in this problem, we still don't know what the compound is. It said it was carbon and oxygen together. Okay, so now we're going to be able to see what the compound is by finding its molar mass. So this is maybe one of those situations where you have an unknown compound and all you know is the density. And if we can figure out what the molar mass is, then we are going to be able to figure out what the compound is, how many carbons or how many oxygens are involved. Okay, so let's go ahead and do the 1.964, and we're just going to multiply it because it's on top right here. The 22.4, and that's going to give us 43.99. We need 3 sig figs, so that's going to round up to 44.0 grams per mole, or you could of course write it out grams per mole like this, or like this. Either way is great. And on this last slide here, I just want to go ahead and show you one kind of helpful thing that helps me. It's also in your book, and you'll also be able to use this on your test. I like to think of the mole as kind of our in-between guy for everything else. Okay, so if you think about volume being here, it's kind of just a good visual thing, and we think of our representative particles being over here, and we think about our mass being here. Now we have an opportunity to kind of see the relationship and how we would have to go in between these. So if you started out with representative particles, we would be able to solve for volume. And if you want to solve for mass, then you could solve for mass using the mole. Okay? And so if we are going this way, you're going to be using the 22 point, I'm a bad writer, sideways, 4 liters. Okay, if we are going this way, we're going to be using that 6.02 times 10 to the 23rd. And of course, if we're going this way, we're going to be using our molar mass, or the atomic mass if it's just an element. Okay? And this kind of summarizes all the videos that we've done so far, of course excluding the mole hold, but this is kind of the same kind of visual representation of what the mole concept is. And of course we get this from the periodic table. Okay. All right. Well, this concludes all of our mole conversions. So we are now done, and we are going to be moving on to other interesting information in chemistry. Have a great day.